Today we'll discuss lesson 15 of chapter 3, motion in a straight line. First we will discuss acceleration. Define the term acceleration. Is it a scalar or a vector quantity? Give its unit and dimensions. Acceleration. The rate of change of velocity of an object with time is called its acceleration. It means at what rate your velocity is changing. That is known as your acceleration. It tells how fast the velocity of an object changes with time. Fine. So what is the formula for acceleration? Acceleration equals to change in velocity divided by time taken. Now acceleration is a vector quantity. Why it is a vector quantity? As we know, acceleration is a change in velocity, and velocity is also a vector quantity. That means it has a numerical value and direction. Therefore acceleration is also a vector quantity, means it has a numerical value as well as direction. Now what will be the direction of acceleration? It has the same direction as that of change in velocity. In whichever direction your velocity will be changing, that will be the direction of acceleration. Now the SI unit of acceleration is meter per second square. The CGS, centimeter gram second unit of acceleration, is centimeter per second square. Now the dimensional formula of acceleration is m to the power 0, L to the power 1, t to the power minus 2. Now what you can do is, as your homework, you can take this first question. You will derive how we got this dimensional formula. You know acceleration equals to change in velocity by time taken. Using that formula you can derive the dimensional formula of acceleration. Fine. Now let's take another question for your homework. The position of an object moving along x-axis is given by x equals to a plus bt square, where a equals to 8.5 meter, b equals to 2.5 meter per second square, and t is measured in seconds. What is its velocity at t equals to 0 seconds and t equals to 2 seconds? What is the average velocity between t equals to 2 seconds and t equals to 4 seconds? Here they have given you the position of the object, which is x equals to a plus bt square. Here they have given you the value of a, 8.5 meter, the value of b, 2.5 meter per second square. And they have said that t is measured in seconds. Now what you have to do, you have to find out the velocity. So first you will find out the velocity using this relation. After you find out the velocity, you will substitute time t equals to 0. You will substitute the value t as 0 seconds and t equals to 2 seconds. After you have found out this one, you will go to the second part of the question. What is the average velocity at t equals to 2 seconds and t equals to 4 seconds? What you will do, you will again substitute time 2 seconds and t equals to 4. So you will find out the velocity at 2 seconds. You will find out the velocity at 4 seconds. After you have find out the velocity, to find out the average velocity, what you do, you add these two values and divide it by 2. Fine. This will give you the average velocity. Fine. Now let's move to another topic. Kinematic equations for uniformly accelerated motions. Now in this topic, I will derive 3 equations. Now those 3 equations are very important. Fine. So let us derive our first equation, that is the velocity after certain time. But before that, let's give a introduction. equations for uniformly accelerated motion along the straight line. All these equations are for the body which are moving in uniform acceleration. That means the acceleration is changing at a constant interval. Fine, it's not randomly increasing or decreasing. If it's increasing also periodically, if it's decreasing also periodically, that is your uniformly accelerated motion. Now consider an object moving with a constant acceleration along a positive direction of x-axis. So suppose you have an object. This object is moving along x-axis and it is moving along the positive x-axis. So let us suppose this position is initially at this point O, or I can say 0. At time t equals to 0, this point is at x0, at which time t equals to 0. And what is the velocity of this point at this point? v0. Now after some time t, this velocity or this object moves up till this point. This point is your x at time t. And what is the velocity at this instant? It is v. So x0 is the position of the object at t equals to 0 seconds. X is the position of the object at instant t. v0 is the velocity of the object at instant t equals to 0. And v is the velocity of the object at instant t. Now we will derive our first equation, velocity after certain time. Now you know the acceleration. Acceleration equals to change in velocity divided by time taken. So what was your final velocity? V. What is your initial velocity? v0. So change in velocity, v minus v0 divided by time taken. Finally the time was t and initially the time was 0. So how much time it take? T minus 0. Fine, so t minus 0 is t. I can take this t here. So at equals to v minus v0. Now to find out the final velocity, I can send this initial velocity here. So v equals to v0 plus at. This is the required velocity time relation. Fine. So if in a question they have given you the initial velocity of the particle, they have mentioned about the acceleration, and they have given the time, then you can find out the final velocity and vice versa. Fine. Let's move to the next equation. Distance covered in a certain time. Now, average velocity of an object at time interval 0 to t is given by, we know velocity equals to displacement by time taken. Velocity is displacement by time taken. Velocity is displacement by time taken. So this is x minus x0 divided by t minus 0. Fine. Displacement is the distance between your final position and your initial position. Now t minus 0 is t. I can send this t here. So x minus x0 can be written as v average times t. Fine. Now v average, we also know that average velocity can also be written as initial velocity plus final velocity divided by 2. My initial velocity was v0, my final velocity is v divided by 2. So I can substitute this v average here. So I can write x minus x0 v0 plus v divided by 2 times t. Fine. Now in your v equals to v0 plus at. Let us substitute it here. So v0 plus v0 becomes twice of v0, and here at divided by 2 times t. Now if I divide this 2 here, so this 2 and this 2 gets cancelled. So I have v0 multiplied with t, v0 t. And here what will I have? Half this 2 here, half, and then at at times t will give me a t square. Fine. So x minus x naught equals to v naught half at square. Or if I have to find out your final position x, then I can write x naught plus v naught t plus half at square. Now if in the this equation is your position time relation, because this equation relates your position of the object with time. Now if in the question they have given you the acceleration, your initial velocity and your initial position and time, then you can find out the final velocity, or you can do it vice versa. Fine. That means you can find any value out of this one, given that other quantities have been mentioned in the question. Right? Now you know x minus x naught. What is x? X is your final position, x naught is your initial position. So this is your displacement, or I can say this is also your distance traveled by the object in time t, which is denoted by s. So instead of writing x minus x naught, I can write here s equals to v naught t plus half at square. Now this is your distance time relation. Fine. Now if in the question they have given you acceleration, they have given you initial velocity and time, you can find out the distance covered by the object in that time. Fine. Now let's move to the next equation. Velocity at certain position. Now velocity at certain position. We know final velocity can be written as initial velocity plus acceleration times time, or I can also write v minus v naught equals to at. Also my average velocity times time should give me this. Velocity equals to displacement divided by your time. So if I have to find out displacement, this will be velocity times time. I can say average velocity times time. So average velocity times time give me. Now you know average velocity is final velocity plus initial velocity divided by 2. So I can substitute this formula here. Times time equals to displacement is the distance between your final position minus your initial position. Fine. I can write this 2 below t. Now I can cross multiply. I can send this t to the denominator and 2 to the numerator. So I have v plus v naught equals to 2 by t times x minus x naught. Fine. Now what we will do, we will multiply our equation 4 v minus v naught at and your equation 5 v plus v naught at. Fine. So on the left hand side I have v plus v naught. Here on the left hand side v minus v naught. On the right hand side I have 2 by t x minus x naught, 2 by t x minus x naught times on the right hand side 80. Fine. Here I can use my x square minus y square relation, or I can say x plus y and x minus y should give me x square minus y square. So v plus v naught and v minus v naught should give me v square minus v naught square. On the right hand side part, t and t gets cancelled, so I have 2a x minus x naught. And if I have to find out the square of the final velocity, I can send this v naught square here. So v square equals to v naught square plus twice of a x minus x naught. And this is an important relation. If they have given you acceleration, they have given you the initial and final position, and they have given you the initial velocity, you can find out the final velocity and vice versa. Now x minus x naught, we know it is the distance traveled by the object in time t, which is denoted with s. So instead of writing x minus x naught, I can simply write it as v square plus v naught square plus twice of as. Final velocity square equals to initial velocity square plus twice of acceleration into distance. Right? So these are your three kinematic equations, and they are very important. In next class, I will derive these three kinematic equations again, because they are very important with respect to your board perspective. But this, in next class, I will be deriving using the graphical method, using your graphs. Right? So that's it for today's class. Thank you. And if you have any confusion, please ask. I will re-explain it to you again. So thank you.